In this last video, we provide an example of the translation of a verbal theory into a formal model using our framework and our methodology. We use the transactional theory of stress by Lazarus and Folkman. Let us begin by recalling some key elements of this theory. Let us consider a person with their own internal parameters, commitments, beliefs, etc. This person is in a specific environment. What the transactional theory of stress expresses is that psychological stress is an appraisal or evaluation of the transaction between the person and the environment. This transaction is deemed stressful if 1. The environment is appraised as endangering the well-being of the person, and 2. If it is considered as taxing or exceeding the resources of the person. Hence, there are two processes involved in appraising a transaction. Primary appraisal, which consists in evaluating whether the environment presents a danger for the well-being of the person, and secondary appraisal, which consists in evaluating whether the environment is taxing or exceeding the resources of the person. Once a person is deemed stressed, they may use coping strategies to deal with the stress and the situation. Let us now dive into the modeling of the theory. We start with a simple sentence describing the process of appraisal. Cognitive appraisal is an evaluative process that determines why and to what extent a particular transaction or series of transactions between the person and the environment is stressful. We model this using two automata. In the first automaton, there is a state called appraisal. There is another state called NA, which means non-appraisal. When we are in state appraisal, we may receive the letter stress or the letter no stress. The second automaton describes the evaluation of stress. Right now it is very simple, but it may be refined into a much more complex mechanism. This second automaton has the role of sending to the first automaton the result of the evaluation, which is here either stress or no stress. We now add another automaton which models the environment. Here, the environment is considered to be a finite state system. Whenever the environment is in a state called X, it sends regular updates to the cognitive appraisal automaton of the state it is in by a transition labeled by X. We can also see that the environment may move from a state X to a state Y by taking a transition labeled by tau. Let us now describe one last step of modeling. Here we model primary appraisal, secondary appraisal, and coping. We can see that in the first automaton called appraisal, the state that was previously just A for appraisal has now been split into two states, PA for primary appraisal and SA for secondary appraisal. We move from state PA to SA by reading the letter S when a situation is deemed stressful, and we move back by reading the letters G or B, which mean good or bad. Let us take a look at automaton 4 to understand what it means. In automaton 4, I begin in a state called ρ. Then, when I read the letter S, I will choose non-deterministically one coping strategy, which is written by C under brackets. In this automaton, for every coping strategy C, there is a transition between the state ρ and the state brackets C, which is labeled by S. When I take S, I simply pick one of these strategies. Once I'm in the state brackets C, I evaluate this strategy, and I either deem it to be good by reading the letter G, in which case I move to the state with double brackets and C, or I deem it to be bad by reading the letter B, and I come back to the state called ρ, and I start another cycle. Once a strategy is deemed good, we model a very simple decision-making mechanism, which is that I immediately take that action. Now I take the transition labeled by C in brown, which will then affect the environment and will allow me to move the environment from one state to another. This brown transition models the action of coping strategies on the environment. Let us note that here we could have modeled any decision-making theory. You can find a published paper on this framework below this video, as well as an extended preprint as well as an extended preprint with many more modeling steps.